Hi, today I'm going to show you our implementation of decision tree, and I'm Xueling from Team Supernova. Okay, now let's see the implementation. We use Java to implement C4.5, and here is the result. As we can see, the result after pruning is worse than the result before pruning. And we think this is because the training data set is not large enough. So here is the implementation details. First, we process input file and have attribute set, target attribute, and instance set, and we construct tree recursively that we choose attribute with the largest information gain as the current node, and we mine data along with tree paths and do cross-validation to test accuracy and avoid overfitting by pruning. Here are some critical problems during implementation. When to stop constructing the tree, we choose to stop until entropy of target attribute equals 0 or no attribute left. This may bring a problem that the tree may be very large, but we can solve it by doing post-pruning. And the second problem is how to deal with continuous attribute. We use dynamic one-cut to binary method. Actually, it works as first we sort all of the instances according to their value of attribute, target attribute, and then we choose, then we find each point that the value of attribute change, and then we calculate the information gain of each point, and we choose the point that with the largest information gain as the cutting point, and then we calculate the threshold, and then we separate the instances to two subsets, and then we do what we do as the how we dealing with the discrete attributes. And the last problem is which pruning method to choose. We choose to use reduced error pruning, and I will show you details when we see the source code. Okay, now let's see the source code. Okay, so let's from here we have a package called tree definition, and here is the definition of tree node. And because time is limited, I will show you some most important things. Okay, and we have data definition, and then here's attribute and instance. Okay, and we also have a class called process input, and we process input in this class, and we have also another process output, and we print the tree using DFS, and we print each path from root to leaf. And we the most important is C4.5 core algorithms. And first, let's see how we calculate entropy. And here we can see we have a method called calculate and another method called calculate continuous. So why do we have different method for these two? Actually, we just want to, because in this method we have start to end, and then we can use the original array list, and instead of making new array list, so which can save space and time. And for information gain, we have two different class. One is information gain discrete, another is information gain continuous. So this is important to have two different, because they have different methods to dealing with a different type of data. For discrete is easy, we just based on the math stuff to calculate it. But for continuous is much more complicated. As I said before, we use dynamic one cut to binary method. And first we sort and we calculate each information gain of changing point and choose the one with maximum information gain and calculate threshold and initialize subset. Okay, so then we can choose attribute to find the largest one. So we deal with it separately for a continuous and discrete attribute, and we construct the tree recursively. And here is when we stop, and here is how we choose root attribute, and then we construct the tree. Okay, so here is the core algorithms, but we have more because we do planning. So here is the planning. We how the planning works. Um, Actually, we'll first do planning for one branch, each branch, and we see whether um, the accuracy of this branch will increase after planning. If it increase, we will do planning to this branch. If it doesn't increase, we'll keep the original branch. And how we define the accuracy, we use cross-validation, and we also have a cross-validation with planning. And uh, the original cross validation is easy, so we will not see it. For the with planning cross validation, the most important part is we separate the data set to three parts. We use 6 of 10 to as training data set, and we use 3 of 10 as the planning data set, and we use 1 of 10 as the test data set. Okay, so we do the cross validation as this. And then let's see the main class, and this is the entrance of our program. Okay, so I think that's it. Because time is so limited, I can only explain this much to you. And if you have any question, you can send me email to ask us. And if you want to see our source code, you can just go to our Bitbucket. Okay, and yeah, things about this what I want to show with you. Wish you enjoy it. Thank you very much.